So, box of mass 18 kilograms at rest on a horizontal frictionless surface. So frictionless, you should notice that there straight away. You're not going to have a component of friction acting this way. A force of 4 newtons is applied to the box at an angle of 26 degrees to the horizontal. Show that the horizontal component of this force is 3.6 newtons. So it makes it quite easy for you there. That's your horizontal component of force along there. Remember, it's cos for in the horizontal direction here. So FH is going to be F cos theta. So it's going to be 4 cos 26 degrees, which will give you the 3.6 newtons required. Calculate the acceleration of the box along the horizontal surface. So you now know you've got a horizontal force acting this way of 3.6 newtons. You're told in the question that there is no friction here, so the unbalanced force is all in the forwards direction. Your unbalanced force is 3.6 newtons. So that goes into F equals ma, where F is always the unbalanced force. So that's 3.6. Its mass is given as 18 kilograms. So it's 18A. A will be 3.6 divided by 18, which gives 0.2 meters per second squared. Part 3, calculate the horizontal distance travelled by the box in a time of 7 seconds. So for any motion, whether it's at an angle, whether it's a projectile motion, you know you're going to use your equations of motion. So write down suvat and write in what you've got. S is pretty much what you're looking for, so you don't have that. It says starts at rest, so U is 0 meters per second. V, you don't know what its final speed's going to be. You do know its acceleration because you've just calculated it. It's 0.2 meters per second squared, and you're given that it's a time of 7 seconds, so you just choose the right equation from there. You're looking for S, you've got UA and T, so I would use ut plus a half at squared. That becomes 0 because u is 0 plus a half times 0.2 multiplied by 7 squared should give you 4.9 meters. Last part there, quite a difficult one. The force is applied for the same time as before, but it's at an angle of less than 26 degrees. How does the distance travelled by the box compare with your answer to part 3? So you've got to compare it to this answer here of 4.9 meters. Well, the angle has decreased, so you've still got a horizontal component of force, but there's more of that force within the horizontal direction. So your horizontal force has increased. If your horizontal component of force has increased, that means that this unbalanced force here must also increase. And if an unbalanced force increases, what does it do to acceleration? It causes acceleration to increase. If you've got a greater acceleration, you're going to go faster, so therefore S is going to be greater. You can look at it mathematically like that, just work through from start to finish. That's what these questions always ask you to do, is to just look at the problem again, but from a different perspective with a different value. So you can either just look at it mathematically and see how it changes, or you could plug a value in there. You could do up here 4 cos 25 degrees, and then you get a different value. You could work that through that way. You'll still get the 2 marks whichever way you do it. So you can either look at it mathematically, look at how it will change as you work through your question from start to finish, or put in values, put in a new value at the start and work it right the way through.